my pleasure to welcome you again to this edition of our tutorial. And today we will be concluding the lesson we started on indices. Today we shall be looking at indices leading to simultaneous equation. Some indices can lead you to simultaneous equation, some can lead you to quadratic equation. So first we'll take the ones that lead to simultaneous equation. We have a question already on the board. The question says, if 3 raised to power x plus y is equal to 81 and 25 raised to power x minus y is equal to 5 raised to power minus y, determine the value of x and y. We will create two equations from these indices. We have 3 raised to power x plus y is equal to 81. This will be 3 raised to power x plus y is equal to 3 raised to power 4. The index form of 81 is 3 raised to power 4. So we take out the base since they are equal. So x plus y is equal to 4. This becomes our equation 1. Then we create the second equation from the second mathematical statement, which says 25 raised to power x minus y is equal to 5 raised to power minus y. Now the index form of 25 is 5 raised to power 2 into bracket x minus y is equal to 5 raised to power minus 5. Now the bases are equal. Let's take them out. If we open this bracket, we will have 2x minus 2y is equal to minus 5. This becomes our equation 2. So now we're going to use the substitution method for solving simultaneous equation. So let's make x subject in equation 1. Equation 1 is x plus 4 equal to x plus y is equal to 4. So if you make x subject, this will be 4 minus y. Then substitute x is equal to 4 minus y into equation 2. Now permit me to move to this other side of the board. Now if we substitute, don't forget our equation 2 says 2x minus 2y is equal to minus 5. Now if we substitute the value of x, this will be into bracket 4 minus y, because x is equal to 4 minus y. Minus 2y is equal to minus 5. So if you open your bracket, you have 8 minus 2y minus 2y is equal to minus 5. Then this will be 8 minus 4y equal to minus 5. We collect like times, we have minus 4y is equal to minus 5 minus 8. So minus 4y will be equal to minus 13. If we divide both sides by 4, it will be minus 13 over minus 4. So y is equal to 13 over 4, because minus can take out minus. So we already got our value of y. We substitute y is equal to 13 over 4 into equation 1. If you recall, our equation 1 is x plus y is equal to 4. So x plus the value of y is now 13 over 4 is equal to 4. So if you collect like times, x will be equal to 4 minus 13 over 4. Now, the LCM of 1 and 4, if I continue from this part of the board, the LCM of 1 and 4 is 4. 1 in 4 is 4. 4 times 4 is 16. Minus 4 in 4 is 1. 1 times 13 is still 13. So 16 minus 13 will give us 3 over 4. So when our y is equal to 13 over 4, our x is equal to 3 over 4. That's the value of x and y. Alright, we have example 2 on the board. If 16 raised to power 1 minus x is equal to 64, and x minus y is equal to minus 3 over 2, find the value of x and y. Now, so 16 raised to power 1 minus x is equal to 64. 16, the index form is 2 raised to power 4. To bracket 1 minus x is equal to, the index form of 64 is 2 raised to power 6. Now, you have, let's take out the bases since they are equal. 4 times 1 is 4 minus 4x is equal to 6. So if you collect like terms, you're going to have minus 4x is equal to 6 minus 4. So minus 4x will be equal to 2. So our x, if you divide both sides by minus 4, you have 2 over minus 4. And this will be, if it's broken down further, it will be minus 1 over 2. This is the value of x. So we substitute x is equal to minus 1 over 2 into equation 2. We have not created equation 2. Okay, the equation 2 is clear already. That is x minus y is equal to minus 3 over 2. If we cross multiply, you have 2 into bracket x minus y is equal to minus 3. So this will give us 2x minus 2y is equal to minus 3. Recall that the value of x now is minus 1 over 2. So if we slot in the value of x, we will have 2 into bracket minus 1 over 2, bracket close, minus 2y is equal to minus 3. So these 2 can cancel this 2. If that been done, you have minus 1 minus 2y is equal to minus 3. So if we collect like terms, we have minus 2y is equal to minus 3 plus 1. So minus 2y will be equal to minus 2. So our y will be minus 2 divided by minus 2. Y is equal to 1. So therefore, when our x is equal to minus 1 over 2, our y is equal to 1. Okay, let's take example 3, and that will be the last example under this subheading. Now it says if 9 raised to power 1 minus x is equal to 27 raised to power y, and x minus y is equal to minus 1 whole number 1 over 2. Find the value of x and y. Now let's create our equation 1. Now 9, 1 minus x is equal to 27 raised to power y. The index form of 9 is 3 squared. That's 3 raised to power 2 into bracket 1 minus x is equal to the index form of 27 is 3. So since the bases are equal, we can take them out. If we open this bracket, you have 2 times 1 minus 2 times x is equal to 3y. We have created our equation 1. Now our equation 2 is already there, but we can make it clearer. X minus y is equal to minus 1 over number 1 over 2. We just need to convert this to an improper fraction. This is a mixed fraction. So you have x minus y is equal to minus 2 times 1, 2 plus 1, 3. 3 over 2. So if we cross multiply, we'll have 2 into bracket x minus y is equal to minus 3. Then, if we open this bracket, you have 2x minus 2y is equal to minus 3. So we have created our equation 2. Alright, how do we make this easy? Now, we're going to use substitution method to solve this question. Now, in using substitution method, let's make x subject. In equation 1, and then substitute it in equation 2. Now, if you're making x subject, you have 2 minus 2x is equal to 3y. If you collect your like terms, bringing 2 to this side, you have 3y minus 2. And then, if you divide both sides by 2, you're going to have x is equal to 3y minus 2 divided by minus 2. So our x is equal to minus 3y minus 2 over 2. Now we substitute x is equal to minus 3y minus 2 over 2 into equation 2. Let's move to this side of the board. Now, let's recall that the equation 2 is 2x minus 2y is equal to minus 3. If we substitute that value of x, 2x, 2 will be minus 3y minus 2 over 2. Minus 2y is equal to minus 3. So, these 2 can cancel these 2. And then we have minus 3y, minus times plus will give us, minus times minus will give us plus 2. Minus 2y is equal to 3. So if we collect like times, we have minus 3y minus 2y is equal to minus 3 minus 2. This will give us minus 5 equal to minus 5. So if we divide both sides by 5, y would be equal to 1. We have gotten the value of 1. Then we substitute y is equal to 1 into equation 1. Recall that our equation 1 is 2 minus 2x is equal to 3y. Then 2 minus 2x is equal to 3 times 1. And then we have 2 minus 2x is equal to 3. Minus 2x is equal to 3 minus 2. And minus 2x is equal to 1. Our x is equal to 1 over 2, minus 2. So when our y is equal to 1, our x is equal to minus 1 over 2. Now the question says determine the value of x plus y. So we are adding the 2. X plus y will be, the value of our x is minus 1 over 2. And the value of our y is 1. Now minus, if you subtract half from 1, it will give you half. So therefore x plus y is 1 over 2. there are some indices that often lead to quadratic equations. Whenever I see indices of this form, it will often lead you to a quadratic equation. Now, if you are to rewrite this power actually means times 3 raised to power 1, where was the power that was added to these two to make it 2x plus 1. Now, we also have the same issue here. 3 raised to power x, this is times 3 raised to power 1 also. Don't forget 3 raised to power 1 is still 3. So plus 9 is equal to 0. So if we multiply this 3, let's enclose this 3 inside the bracket, and then let's multiply this 3 by the 4 outside. 3 raised to power x plus 9 equals to 0. Now, this can be written as 3 into bracket 3 raised to power x, then raised to power 2. If you multiply 2 by x, you still get 2x minus 4 times 3. This will give us 12 plus 9 equals to 0. Now, you can use any alphabet, but let's use b. Let b be equal to 3 raised to power x. So wherever you see 3 raised to power x, you replace it or you substitute it with b. If we do that, we will have 3b squared minus 12b plus 9 is equal to 0. We have created a quadratic equation from this. Now this quadratic equation is a bit cumbersome. We can break it down by dividing through. Divide through by 3. Now if we do that, we have 3b squared minus 12b plus 9 is equal to 0. Now divide each term by 3. If you divide 0 by 3, you still get 0. So this 3, you can cancel this. You have b squared minus 12 divided by 3 will give us 4b plus 3 is equal to 0. We can factorize this. How do we factorize? We look for two numbers whose product is equal to 3 and whose sum or subtraction is equal to 4. Now those two numbers are 3 and 1. B squared minus 3b minus b is like 1b. So 1b is still 1b, is still b, plus 3 is equal to 0. So we factorize now. The factor here, you factorize by grouping. The factor here is b. So let's put b outside the bracket. B squared divided by b is b minus 3. Then the factor here is minus 1. b minus 3 is equal to 0. So when you're factorizing, what you have in this bracket must be the same thing what you have here, so that you can pick one of the bracket and pick the two items outside. So you have b minus 3 is equal to, b minus 3 into bracket b minus 1 equal to 0. So for the product of these two brackets to be equal to 0, is either one of them must be 0. So either b minus 3 is equal to 0 or b minus 1 is equal to 0. So if you collect items, b will be equal to 3. Of course, if this 3 is crossing to this 3, it becomes plus. Or b is equal to 1. Okay. Now recall that b is equal to 3 raised to power x. From here we said let b be equal to 3 raised to power x. And we have gotten our b to be 3. So we equate the two of them. So we can say 3 raised to power x is equal to 3. b is also equal to 1. So you have 3 raised to power x is equal to 1. So 3 raised to power x is equivalent to 3 raised to power 1 because 3 raised to power 1 is still 3. Since the bases are equal, you take them out, x is equal to 1. So, here also, 3 raised to power x is the same thing as 3 raised to power 0. Recall that we said anything raised to the power of 0 is 1. So if you take out the basis, s is equal to 0. So when b is equal to 3, x is equal to 1. And when b is equal to 1, x is equal to 0. So this form always gives you 4 answers. When b is equal to 3, s is equal to 1. And when b is equal to 1, s is equal to 0. Alright, we'll take example 2. That will be our final example for this class. Now you have 9 into bracket 3 raised to power 2a minus 1 minus 10 into bracket 3a is equal to minus 3. You have your 9 into bracket 3 raised to power 2a. This is equivalent to times 3 raised to power minus 1. Please note that. Now, minus 10, 3a. You bring this 3 over. And when it is crossing, the sign of equal to it becomes plus. Then you equate everything to 0. So, this is 9 into bracket 3 raised to power 2a times 1 over 3. Already established that in our first class. Minus 10 into bracket 3 raised to power a plus 3 is equal to 0. So this 3 can cancel out 9 and then you have 3. So what you have here will be 3 into bracket 3 raised to power 2a minus 10 into bracket 3 raised to power a plus 3 is equal to 0. Don't forget this can be written as this 3 raised to power a, then 2 minus 10 into bracket 3 raised to power a plus 3 is equal to 0. So this time around, let's use x. Let x be equal to 3a. That means wherever you see 3a, you replace it with x for now. Then you have 3. If 3 replaces this, if x replaces 3a, you have 3x squared minus 10x plus 3 is equal to 0. So we factorize this. This is actually easy to factorize. Now, in factorizing this is a quadratic equation with a first degree coefficient. So you multiply the first degree coefficient by 3. That will give you 9x squared. So indirectly what you're looking for is two numbers whose product will give you 9, not 3. And whose sum or subtraction will give you 10. Now those two numbers will be 1 and 9. So if we substitute those two numbers with the middle term, we will have 3x squared minus 9x minus x plus 3 equal to 0. So the factor here is 3x. into bracket x minus 3. And the factor here is minus 1 into bracket x minus 3. If you expand this, you get this. Don't forget when you're factorizing, whatever you have in this bracket must be the same. If they are different, it means that that factorization is wrong. Equal to 0. So you pick one of the bracket x minus 3 into bracket 3x minus 1 is equal to 0. So for the product of these two brackets to be equal to 0, it's either x minus 3 is equal to 0 or 3x minus 1 is equal to 0. If you collect your like terms, you will have x is equal to 3 or 3x is equal to 1. If this minus 1 crosses here, it becomes plus. So if you divide both sides by 3, you're going to have x is equal to 3. X is equal to 3. Now if you would recall that our x was initially equal to 3 raised to the power a. Recall that x is equal to 3 raised to the power a. So that means our 3 raised to the power a is equal to 3 here. Or our 3 raised to the power a is equal to 1 over 3. So this is equivalent to 3 raised to the power 1. The bases are equal, you cancel them. A is equal to 1. So, and here we also have 3 raised to the power a equal to 3 raised to the power minus 1. This is established already from our rule of indices. So if you take out the bases, a is equal to minus 1. So when x is equal to 3, our a will be equal to 1. And when x is equal to 1 over 3, our a will be equal to minus 1. So this is your final answer. I have taken my time out to select some questions for you to solve. They are here, you can just solve all of them. They are not too difficult questions. Make sure you do it to assess the level of understanding or assimilation of what has been taught. Thank you. Thank you for listening.